Hello friends, my name is Praveen Sonone and you are watching my channel Soumya Academy. In today's lecture, we will see the physical quantities, their definitions, their SI unit, CGS unit and its dimensions. So let us start with very first physical quantity, that is distance. Distance is nothing but the total path length of a particle in a given time. It is scalar quantity. Its SI unit is meter, right? And CGS unit is centimeter. Its dimension L1, M0, T0. Okay. Next physical quantity is displacement. Displacement is nothing but the change in position of an object with a certain distance in a specified direction in a straight line is called as displacement. It is a vector quantity because it has a direction. Its SI unit is meter, its CGS unit is centimeter, and its dimension is L1, M1, M0, T0. Now, next physical quantity is speed. Speed is the rate at which an object covers a distance, right? It is scalar quantity. Its SI unit meter per second, its CGS unit centimeter per second, its dimension is L1, M0, T minus 1. Okay, next physical quantity, velocity. Velocity is nothing but the rate of displacement with respect to time. The rate of change of displacement with respect to time. It is a vector quantity. Velocity equal to distance upon displacement upon time. SI unit meter per second, CGS unit centimeter per second, and its dimension is L1, M0, T minus 1. Now, next physical quantity is angular velocity. Angular velocity is defined as the rate of angular displacement with respect to time. It is vector quantity. Its formula is omega equal to theta upon t. Its SI unit is equals to radian per second. Its CGS unit radian per second, and its dimension is L2 M0 T minus 1 or L0 M0 T minus 1 radian 1. L0 M0 T minus 1 or L0 M0 T minus 1 radian 1. Next physical quantity, force. The physical quantity which change or tends to change the rate, the position of an object is called as force. It is a vector quantity. Force is a vector quantity. Its formula is force equal to mass into acceleration. That is mass into distance upon time square. Okay. Its SI unit Newton. Force SI unit आहे Newton. It means kg meter per second square. Its dimension L1, M1, T minus 2. Now next one is acceleration. Acceleration is nothing but the rate of change of velocity with respect to time. Okay, it is a vector quantity. Its formula is equal to acceleration equal to velocity upon time. Its SI unit meter per second. Its CGS unit centimeter per second square. Its dimension is L1 M0 T minus 2. Right? Next physical quantity is temperature gradient. Temperature gradient is nothing but the temperature upon distance. Its dimension m0 l-1 t0 k1. Next, work. Work is nothing but the product of force and displacement is called work. It is a scalar quantity because it has no direction. SI unit. SI unit is joule, kg meter square per second square. 1 joule equal to kg meter square per second square. Right? Its CGS unit is erg or kg centimeter square per second square. Its dimension L2 m1 t minus 2. Next quantity, energy. Energy is nothing but the capacity to perform work is called energy. It is a scalar quantity. Its formula equal to force upon displacement. Now SI unit, joule, that is kg meter square per second square. It means the unit of work and energy is same. CGS unit equal to erg, that is kg centimeter square per second square. So the dimension of work and energy is same, that is L2 m1 t minus 2. Now next one is power. Power is nothing but the rate of doing work is called power. It is a scalar quantity. Its formula equal to work upon time. Its SI unit is equals to joule per second, that is kg meter square per second cube. Its CGS unit erg per second, that is kg centimeter square per second cube. Dimension L2 m1 t minus 3. Now next quantity is density. Density is nothing but the mass per unit volume is called density. It is denoted by rho. It is a scalar quantity. Its formula equal to m upon v. SI unit kg per meter cube. CGS unit gram per centimeter cube. And its dimension L raised to minus 3 m1 T0. Now next quantity is pressure. Pressure is nothing but the force exerted perpendicularly per unit area. It means force upon area. It is a scalar quantity. Its SI unit is Pascal, that is Newton per meter square, that is kg per meter second square. CGS unit dyne per centimeter square. Dimension L minus 1 m1 t raised to minus 2. Next physical quantity is momentum. The product of mass and velocity of an object is called as momentum. It is a vector quantity. Its formula P equal to mv. Momentum is denoted by capital P. Its SI unit kg meter per second. Its CGS unit gram centimeter per second. Its dimension L1 m1 t raised to minus 1. Next physical quantity is impulse. It is the change of momentum of an object when the object is acted by a force for interval of time is called as impulse. So it is a vector quantity because it has a direction. It is denoted by capital J. So J is equals to F into T. Its SI unit Newton second, that is kg meter per seconds cube. Its CGS unit gram centimeter per second cube. Its dimension L1 M1 T raised to minus 1. Now next physical quantity is torque. Torque is the twisting force that change to cause the motion. It is a vector quantity. It is denoted by tau, that is its formula tau equal to F into R. SI unit Newton meter, that is also called as kg meter square per second square. Now dyne centimeter, it is gram centimeter per second square. It means L2 M1, dimension of torque L2 M1 T raised to minus 2. Now next physical quantity is area. Area is the quantity that expresses the extent of two-dimensional shape, that is called as area. It is a scalar quantity. Its SI unit meter square. Its CGS unit centimeter square. Its dimension L2 M0 T0. Now next physical quantity is volume. Volume is the quantity of three-dimensional space enclosed by closed surface, right? It is a scalar quantity. Its area is meter cube. SI unit is meter cube. Its CGS unit centimeter cube. Its dimension L3 M0 T0. Next physical quantity is kinetic energy. The energy possessed by the body by virtue of its motion is called as kinetic energy. It is a scalar quantity. Its formula is equals to 1/2 mv square. Its SI unit joule, that is kg meter square per second square. Its CGS unit erg, that is kg centimeter square per second square. Its dimension is equals to kg meter square. Its dimension is equals to L2 M1 T raised to minus 2. Now next physical quantity, potential energy. That is potential energy, the energy possessed by the body by virtue of its motion is called as potential energy. The energy possessed by a body by virtue of its position is called as potential energy. It is a scalar quantity because it has no direction. Its formula is mgh. The SI unit is joule or kg meter square per second square. Its CGS unit is erg, kg centimeter square per second square. That is kinetic energy and potential energy has same SI unit, CGS unit and dimension, right? That is L2 M1 T minus 2. Now next physical quantity is resistance. Resistance is the opposition that the substance offers to the flow of electric current. It is a scalar quantity. Its formula R equal to V upon I. Its SI unit is ohm, that is kg meter square per s cube a square. Its CGS unit is erg, that is gram centimeter square per second cube a square. Its dimension L square M1 T minus 3 A2. Now, next physical quantity is electric charge. The property of a particle like protons and electrons which produces electrical influence is called electric charge. It is a scalar quantity because it has no direction. Its formula is Q equal to I into T. Its SI unit is Coulomb or AS. Its CGS unit is stat Coulomb. Its dimension L0, M0, T1, A1. Now, next physical quantity is magnetic flux. The magnetic lines of forces passing normally through the given area is called as magnetic flux. It is a scalar quantity. Its SI unit is Weber. Its CGS unit is Maxwell. Its dimension L2, M1, T minus 2, A minus 1. Now, next is constant, that is Planck's constant. A fundamental constant equal to the energy of a quantum of electromagnetic radiation divided by its frequency with a value of 6.626 into 10 raised to minus 34 joule second. The SI unit of Planck's constant is joule second, that is kg meter square per second. CGS unit is erg second or gram centimeter square per second. Dimension is L2 M1 T minus 1. Next physical quantity is electric capacity or capacitance. It is an electric phenomenon whereby an electric charge is stored is called as capacitance. Its SI unit is Faraday. Its CGS unit is stat Faraday. Its dimension L minus 2 M minus 1 T4 A square. Magnetic permeability. It is the measure of the ability of material to support the formation of magnetic field within itself is called as magnetic permeability. Its formula is mu equal to B by H. Its SI unit is Henry per meter or Newton per ampere square. Its CGS unit Dyne per ampere square. Its dimension L1 M1 T raised to minus 2 A raised to minus 2. Now the next physical quantity is pole strength. The pole strength of a magnetic pole to attract the magnetic material towards itself is called as pole strength. It is a scalar quantity. Its formula is M equal to F upon B. SI unit is Coulomb or ampere second. Its CGS unit is stat Coulomb. Its dimension L0 M0 T1 A1. Now next physical quantity is stress. The internal resistive force per unit area is called as stress. It is a vector quantity. Stress is equals to F upon A. SI unit is Newton per meter square or kg meters per second square. CGS unit Dyne per centimeter square or gram centimeter per second square. Dimension L raised to minus 1 M1 T raised to minus 2. Now next is strain. It is defined as changing length per unit original length. It is the ratio of same quantities, so it has no unit. So it is dimensionless quantity. Next quantity is moment of inertia. Moment of inertia of a body about a given axis is defined as the sum of product of mass of each particle of body and square of its distance from the axis of rotation, that is its formula is equals to I equal to mr square. Its SI unit kg meter square, CGS unit gram centimeter square, dimension L2 M1 T0. Now next physical quantity is surface tension. Surface tension is the property of liquid due to which its free surface tries to have a minimum surface area and behaves like a stretched electric membrane. Its formula is T equal to F upon L. Its SI unit is Newton per meter or kg per centimeter square. Its CGS unit is dyne per centimeter or gram per centimeter square. Now next physical quantity is its dimension L0 M1 T raised to minus 2. Next physical constant is gas constant. It is denoted by capital R. Its SI unit joule per mole per Kelvin. Its CGS unit erg per mole per Kelvin. Its dimension L2 M1 T minus 2 theta minus 1 mole minus 1. Next is Boltzmann constant, that is denoted by K. Its SI unit joule per Kelvin. CGS unit erg per Kelvin. Its dimension L2 M1 T minus 2 theta minus 1. Next is Wien's constant. It is denoted by small b. Its SI unit meter Kelvin. Its CGS unit centimeter Kelvin. Its dimension L1 theta 1. Next is Stephan constant. Its SI unit watt per meter square per Kelvin raised to 4, that is joule per second per centimeter square per Kelvin raised to 4. Here 1 joule equal to kg meter square per second square. Next is erg per CGS unit is erg per second per centimeter square per Kelvin raised to 4. Its dimension L1 M1 T raised to minus 3 theta raised to minus 1. Next is gravitational constant. It is denoted by capital G. Its SI unit Newton meter square per kg square. Its CGS unit dyne centimeter square per gram square. Here dimension is L cube m raised to minus 1 t raised to minus 2. So these are the important physical quantities. सो मित्रांनो, तुम्हाला जर व्हिडिओ आवडला असेल तर लाईक करा, शेअर करा आणि सबस्क्राईब करा. कोणाला काही अडचणी असतील तर कमेंट करून नक्कीच पाठवा.